Alright, so this chapter is going to go into a little bit more of two-dimensional geometry, and we're going to start off with talking about triangles. So there's kind of two ways for us to be able to classify triangles. We can talk about the triangle's angles, and we can talk about the triangle's sides. So every triangle that we're going to encounter is actually going to have two names, an angle name and a side name. To start off, acute triangle means that you have three acute angles, so all these angles in here are all smaller than 90 degrees. Kind of the easiest way to think about it. If we go obtuse, obtuse has one obtuse angle, and that would actually be found right here. If you look at it, it's greater than 90 degrees then. Obtuse, I think obese, so it's a very large angle. A right angle has one right angle, and in our presence here, that would be right there. The right angle is going to be worth 90 degrees. If it has it, it's going to have this little square mark in it. That's going to signal to you that that's a 90-degree angle. We're going to see that in the future for other things too. So that's how we talk about the angles. Are they all acute? Is there one obtuse, or is there one right? Those are your options there. When we talk about sides, we go equilateral, isosceles, or scalene. In an equilateral, you can kind of see the start of the word equal, and you're going to have three what we call congruent. Congruent is just a fancy word for equal in math, sides. And what we'll do is we'll actually put these little tick marks on the sides. And if you see those three tick marks there, that's going to signal to you that all those three sides are going to have the same exact length. In an isosceles, some people say I see two triangles, there are at least two congruent sides. So for example, these two sides would actually be congruent to each other. This one could be a different length then. In a scalene, I call these a scary scalene because they're all different. None of them are congruent. So this might be one length, this could be another, and that could be another. Notice how I'm putting different numbers of tick marks on all the sides? That's how we just show somebody that they're different lengths then. So if you flip over to the next part, special properties of triangles. So this is kind of easy stuff, but sort of three ideas here. Basically, we know a triangle has three sides and three angles. Several properties here. First thing that you need to know is if we look at all the angles inside a triangle, when we add them up, we have to get 180 degrees. So to find the missing measure here, what we can do is 95 plus 50, the two that are given to us so far, that's 145. So to get this missing one, we're going to do 180 minus 145. That's going to give us 35 degrees. If we wanted to write an equation, we could do 50 plus 95 plus n equals 180. That's another more truly mathematical approach, but these two steps will get us the same thing. When we talk about sides and angles, so first thing to realize in this picture, this A is referring to how long the side is, B is that side, C is that side. 1, 2, and 3 are going to be the measures of the angles. So here's what you need to know, and it's going to kind of make sense to you. If this were a triangle right here, pretend my hand is the triangle, this angle down here, kind of think about it as being the hinge. If I close it, this third side gets smaller. If I open it, that third side gets larger. So the larger this angle is, the larger the side across from it is, which means when we see the biggest angle, the side across is going to be the longest side. So if 3 was my biggest angle, that would tell me that C would be my biggest side. Let's just say 1 is the smallest. That would tell me that A, because it's across from it, would be the smallest side. So taking a look at this picture, we have 98, 220, 185. It wants to know which one is the largest angle. Well, the largest angle would happen across from the largest side. So this right here is my largest side. Go back across, angle E is the largest. Just for our purposes, which one would be the smallest? Well, here's your smallest side, go across, angle F would be the smallest, and angle D would be in the middle. If you take a look at the next page, here's another example of this one. Triangle has them, write the sides in order from shortest to longest. So we know the three sides. We're going to go from shortest to longest. So we need the smallest to the biggest. So in our case, this is the smallest angle, so R would come first. So R is going to be smaller than this side across from here, which would be smaller than T, which is going to be smaller than S. S is across from the biggest angle, which means it's going to be the longest side here. And that's how we can actually write them in order then. You'll also notice that if these angles were the same, those side lengths would also end up being the same. That's important for isosceles triangles. In example 3b down here, this one we have the missing angle measurement. So what I would say is 101 plus 37 is going to give me 138. So if I'm trying to find this angle A, I'm going to do 180 minus 138, because remember all three angles add up to be 180. And if I do this, I'm going to get 42 degrees. So this is 42 degrees. So it wants to know what are the side lengths from least to the greatest. So which side is going to be the smallest? The smallest happens across from the smallest angle. So C is going to come first, and it's going to be smaller than this one would come next, which is going to be smaller than B, because B is the largest angle here as well. Okay? So this last section is kind of a little bit easier to sort of demonstrate with kind of a hands-on approach, which we will do in class. Unfortunately, if you have to miss the lesson, you can kind of talk to your teacher and double check in to see what this lesson looks like in person. But what I'm going to do is just kind of explain to you that when we have a triangle, there's a rule that happens, and it's called the triangle inequality theorem. It basically means if we don't know how long a side of the triangle is, it has to fall in between a range of two things. So what we do is we look at the other two sides that are here, and we have to add them together, and we have to subtract them. Now, depending on which one was larger, your subtraction problem might be set up differently. The length of B is going to have to be somewhere in between these two values. So let's actually look at it as an example. Marina uses chalk to draw a triangle on the sidewalk. Two sides have lengths of 15 inches and 22 inches. So let's just say this is my 15-inch side, and that's my 22-inch side. What are the shortest and longest possible lengths of the third side? Assume each side is a whole number, so that is important. Now, if you're thinking, Mrs. Grabner, we could totally draw the triangle like this, but Mrs. Grabner, what if the triangle looked like this? Wouldn't that third side be a lot shorter? And that's exactly what this theorem proves. So since our two numbers are 15 and 22, I'm going to add 15 and 22 together. That's going to give me 37, and then I'm going to do a subtraction problem, but I want to just do the biggest number minus the smaller number, and that gives me 7. So this tells me that the third side has to be somewhere between 7 and 37. It's not allowed to be 7, and it's not allowed to be 37. It has to be between them. So what is the shortest possible length of the third side? If it's between these two, the first available is 8. So 8 inches, and the longest possible would be one less than this, so 36 inches, because it did say they were whole numbers. So these are the shortest and longest possible sides. Now, it could be 9, 10, 11, 12, but it couldn't be something like 40 inches. This inequality theorem narrows it down for us. Is it possible for side lengths 5, 8, and 15 to make a triangle? So here's what we do. We just pick two sides. Leave the third one out as your question mark side. You can pick the first one and the third one and test the second. It doesn't really matter. You're still going to take the two that you're working with. You're going to add them. You're going to do a subtraction problem. So I'm going to get 13 and 3. Is my third number 15 in between 13 and 3? So is 15 between 3 and 13? The answer to that is no. So this is not a triangle. It's not possible. It doesn't actually fit the theorem then. That's the end of our lesson.